Welcome to This Explainer. Every decade has that one specific moment where the future just seems to arrive all at once. And according to TechCon Global, for the 2020s, that moment is 2026. This is the year we hit a massive tipping point. We're talking about the year the software era finally hands the baton over to the physical AI era. Artificial intelligence is no longer just trapped behind our screens. It's quite literally stepping out into the real world. So today, we're going to explore the top 12 emerging technologies that are shaping this incredible transition.
Today's agenda covers 4 key areas. Number 1, software thinks and acts autonomously. Number 2, powering the new AI era. Number 3, AI enters the physical world. And finally, number 4, re-engineering life and space.
Let's dive right into our first section. Software thinks and acts autonomously. Okay, before AI can actually walk around in the physical world, it obviously needs a highly capable autonomous brain. And the advancements we're seeing right now in software development are just staggering. Take $57,000, for example. That is what an indie developer named Peter Levels earns every single month from a flight simulator. Now, here's the crazy part. Using an AI-native development platform called Cursor, he just used simple, natural language prompts to build that entire viral simulator in only 3 hours. It's a trend known as vibe coding, and it is completely democratizing how things are built. By 2026, 70% of new applications will use these no-code or low-code technologies. We're talking about speeding up development by up to 90% and drastically dropping costs. Essentially, the AI brain is now building its own software. And it's not just building software, it's actively defending it too. We're rapidly moving into the era of preemptive cybersecurity. We're no longer just sitting around waiting for a breach to happen and then reacting. AI analytics are now continuously identifying anomalies to anticipate and neutralize threats before they ever even strike. And investment here is absolutely skyrocketing. For example, a cybersecurity startup called A-Strike recently raised $7 million in seed funding for their proactive defense platform. Gartner is even predicting that by 2030, half of all cybersecurity budgets are going to shift entirely away from reactive tools, moving toward these automated predictive early warning systems. We're also refining exactly how these AI brains operate. We're seeing a big shift from general large language models, the LLMs we're all super familiar with, to domain-specific language models, or DSLMs. While general LLMs are great at, broad tasks, they can lack precision. DSLMs, on the other hand, are trained on highly curated specialized datasets. Because they actually understand deep domain terminology, they drastically reduce hallucinations. So if you need a model to interpret really complex legal statutes or generate highly accurate medical reports, a DSLM is much more reliable and honestly significantly more cost-efficient. So the AI brain is getting smarter and much more specialized. But the real leap, that happens when it starts taking action. This brings us to agentic AI. We are completely moving past chatbots that just sit there and answer questions. We're moving to autonomous systems that can perceive real-time data, set goals without any human input, plan multi-step workflows, and then actually execute actions through APIs. A staggering 71% of network operators now plan to deploy these autonomous systems. Just imagine a telecom agent that monitors traffic, spots an outage, reroutes resources, and deploys a software patch entirely on its own. It's a total game changer. All right, moving on to section 2, powering the new AI era. Now that we have this incredibly powerful autonomous brain, we face a massive physical bottleneck. I'm talking about the infrastructure and energy required to actually run it. How in the world do we cool massive AI brains generating over 1,500 watts per square centimeter of heat? To put that into perspective for you, that is like taking the intense heat of a rocket nozzle and concentrating it down onto the size of a postage stamp. Traditional air cooling systems, they tap out at around 100 watts per square centimeter, so they are completely obsolete for the dense AI chips driving this revolution, like NVIDIA's new GB300 GPU, which has a heat flux exceeding that 1,500 watt mark. Bottom line, if we can't cool them, they melt, and the whole software revolution stops dead in its tracks. So the answer to that massive bottleneck is microfluidic cooling. This involves embedding microscopic fluid channels directly into or right next to the silicon chip itself. Instead of just blowing air over the top like we used to, the coolant flows precisely where the heat is being generated inside the hardware. You can think of it kind of like a circulatory system for our new AI brains.
This next-generation solution removes heat up to 3 times more efficiently, and it effectively reduces peak temperatures by roughly 65%. That is exactly what's going to allow future data centers to actually scale up. But alongside keeping chips cool, we also have to make them fundamentally more energy efficient. Enter neuromorphic computing. Traditional chips process data sequentially, which, as you might guess, uses a ton of power. Neuromorphic hardware is quite literally inspired by the human brain. It uses spiking neural networks. What that means is the artificial neurons only fire and consume energy exactly when they're needed, rather than just running continuously. This dramatically drops power consumption, which is absolutely critical if we want to run AI at the edge, like inside robots and IoT devices. And companies are racing to commercialize this right now. BrainChip just launched a $2.5 million project to prototype their Akida 2.0 neuromorphic silicon using a 12-nanometer process, and they're expecting that in Q3 of 2026. And hey, speaking of power, we definitely can't talk about a mobile physical AI era without talking about batteries. $40 per kilowatt hour. That is the astounding projected cost of next-generation sodium-ion batteries as production scales up. Lithium-ion finally has a true heavyweight competitor. KTL, which is the world's largest battery manufacturer, is deploying sodium-ion tech in 2026. These batteries offer a 500-kilometer range for passenger vehicles, they boast a longer cycle life, and they can operate in extreme temperatures, all the way from -40 to +70 degrees Celsius. At nearly half the current cost of some lithium packs, sodium-ion is going to completely rewrite the economics of mobile energy. No doubt about it. Let's shift gears to Section 3, AI enters the physical world. Okay, so we've got the software brain, the cooling, the efficient chips, and the battery power. Now, AI finally gets a body. To anchor this transition, we really just need to look at this powerful declaration made by NVIDIA CEO Jensen Huang at CES 2026. He said, "The ChatGPT moment for robotics has arrived. We are officially stepping into the age of physical AI, where AI models actually understand the laws of physics to control autonomous systems right here in the real world." So, traditional robotics relied heavily on engineers manually coding every single physical interaction. Honestly, it was incredibly rigid. Physical AI, however, uses foundation models, like NVIDIA's Cosmos, that act as learned physics simulators. They give robots a true physical intuition. For example, a physical AI robot doesn't just run a pre-programmed script to tilt a pitcher. It can actually forecast fluid distribution in real time to pour water perfectly, dynamically adapting to the weight and the splash. It's essentially giving machines common sense. And the market is responding explosively to this leap. Industry analysts at TrendForce are projecting a massive 700% growth in global humanoid robot shipments in 2026 alone. This staggering growth is possible because we can now put massive AI compute power directly inside the robot, right at the edge, using highly efficient modules like NVIDIA's Jetson T4000. It delivers incredible processing power at just 40 to 70 watts. That means these humanoid robots can run large language models and vision encoders concurrently without needing to be tethered to some distant cloud server. But we should be clear, physical AI isn't just humanoid robots. It is actively transforming our entire infrastructure and transportation systems. We're seeing intelligent driving become totally mainstream, with L2 plus autonomous systems expected to hit a 64% penetration rate in new cars. Robotaxi services are expanding globally too. We even saw Dubai's Crown Prince taking a self-driving car for a spin recently. Simultaneously, physical AI is taking to the skies to protect us. With the rapid rise of drone threats, AI-powered counter-drone infrastructure, using radar, RS detection, and autonomous neutralization, is actively being deployed to protect things like stadiums, airports, and power plants from rogue airborne threats. And finally, let's explore Section 4, Re-engineering Life and Space. The technologies of 2026 aren't just building smart machines. They are literally re-engineering biology itself and pushing human presence further into orbit. Looking at the biotech revolution, MIT Technology Review highlighted 3 profound leaps moving from the lab into reality. First up, base-edited babies. We've seen personalized treatments like a $1 million treatment for baby KJ successfully correct rare genetic mutations, with clinical trials for infants now planned. Second is gene resurrection. A company called Colossal Biosciences is utilizing ancient DNA to create woolly mice with mammoth traits, and they are even working on engineering dire wolves. And third, embryo scoring. IVF labs and companies like Nucleus are now offering trait selection for things like height and IQ.
Now, as the source material points out, these advancements offer extraordinary medical breakthroughs, but they are also sparking very intense and complex ethical debates regarding eugenics and the broader implications of de-extinction. Moving from our DNA all the way up into orbit, we are witnessing the complete privatization of low Earth orbit. Space stations are no longer exclusively the domain of national governments. The aging International Space Station, well, it's actually scheduled to deorbit in 2031. Taking its place is entirely commercial infrastructure. In May 2026, Vast Space is launching Haven 1, which is a habitat for paying customers and private microgravity research. Following that, Axiom Space plans to launch a boutique hotel station in 2028. The infrastructure for a fully private space economy is quite literally being launched right now. So, from software that basically writes itself, to humanoid robots navigating our factories, to the rewriting of genetics and the commercialization of space, 2026 is truly a year of irreversible trajectories. I want to leave you with this final provocative thought straight from our sources. The technologies are ready. The infrastructure is being built. The only remaining question is how far and how fast we choose to go. As we step fully into this physical AI era, what role will you play in shaping it? Thanks so much for joining me on this explainer, and I highly encourage you to keep exploring these fascinating advancements.